Welcome to the Trusted Computing Group webinar on ICS security using TNC technology. In this webcast, ICS experts and TCG standards contributors will discuss open standards from TCG that provide increased security and protection for ICS environments, and how IT and control systems executives and architects can implement a standards-based, interoperable approach to ICS security. This is a streaming audio event, so if you're having difficulty with the sound, please make sure the sound on your PC is turned on. If you have questions, please type them into the Ask a Question text box at the bottom.
Hi, my name is David Mattis, and I'm the founder and CEO of Asgard Networks. Before Asgard, I was at the Boeing company in the R&D organization, and I have the privilege of being at the beginning when this technology got started at Boeing. As Boeing was transitioning their 777 line from fixed monolithic tooling to mobile lean manufacturing, they had a need to connect mobile tooling equipment to their enterprise wireless networks. The operations group supporting the tooling was looking for a transparent drop-in solution for connectivity for their tools that also met the IT security requirements for connecting to the Boeing enterprise network. Now, this technology has achieved quite an evolution, as we're about to show you today. And while I was there at the beginning, there have been many, many people not on this call today who have greatly assisted and moved this technology forward. And I would like to also thank all of them. Next to you, Eric.
Thanks, David. My name is Eric Byers. I'm the Chief Technology Officer at Tofino Security, part of the Belden group of companies. I'm a process controls engineer from back in the 80s, ended up in telecommunications, and ended up as an academic running the British Columbia Institute of Technology's critical infrastructure security center, research center. And that eventually ended up creating the Tofino product line that specializes in security technologies for SCADA and process control systems, and introduced me to David and the team at Boeing, which got me very interested in the technology available in MAP and how it could really help secure control systems. And it also introduced me to our next speaker, Lisa, who, over to you, Lisa.
Thanks, Eric. I'm Lisa Lorenzen, a Principal Solutions Architect with Juniper Networks. In my role at Juniper, I'm focused on enterprise security and mobility solutions, and I work with many customers who have ICS environments that have requirements for data and network protection. I've also been a contributor to the Trusted Computing Group working on open standards that help with network security and security automation, and I've found that those two interests have converged around open standards for ICS security.
So let's start off and talk a little bit about control systems. If you're familiar with control systems, you probably can go to sleep at this part, but for those of you who are just learning about the wild and crazy world of industrial control systems, or SCADA as a lot of people call it, this is pretty typical. Control systems are not one big monolithic network or one big monolithic type of equipment, but often a collection of different networks, often widely distributed in remote and hard to get to places. For example, the power industry, every substation has its own little network, a substation ICS network, that then interconnects back to a larger network, either over the internet or a wide area network, or often a variety of networks using a variety of technologies. And in those substations, there'll be devices like remote terminal units, PLCs, what we call IDEs, intelligent electronic devices. Traditionally, these weren't networkable, but today they're all migrating to Ethernet and TCP/IP and protocols that we all know and love in the IT world, like HTTP, but also very SCADA-centric protocols like Modbus and DNP3 and the IEC protocols and ICCP and all sorts of different protocols. So what we have here is a very, I would describe it as sort of a heterogeneous mix of different types of equipment, different protocols, and actually different networks that are all connected with different communications. And that makes life a little tricky. David, any thoughts on that?
Yeah, I just would like to add that we're increasingly taking advantage of modern shared network capabilities like cellular connectivity. We have, and I think everybody can appreciate the value of adding an additional layer of security on top of these environments, an additional layer of connectivity management and security, and particularly also these types of industrial controls equipment have very long life cycles that often long outlast the network configurations themselves of the internet and cellular providers. Lisa, any last thoughts on this slide?
Well, I think that's a great point because it leads us to the challenges inherent in such an infrastructure. And Eric, maybe you can tell us a little about that?
Yes, because all of this equipment has been with us now for 40 to 50 years, SCADA equipment and process control equipment in an electronic format. And as David said, it's sticking around for a long time. In the IT world, we're used to throwing out our laptops every 3 or 4 years. If something's got a terrible security flaw, just get rid of it. But in the control system space, the tradition is to keep equipment for 20 to 25 years. And this equipment that's been out there was designed for safety, not security. Many of the applications are seldom patched, or the operating systems are seldom patched, not because they don't want to patch them, but because patches can impact production. Patches stop production while you patch. And so things are poorly patched. They're all very susceptible to a variety of attacks as a result, and they lack a lot of capabilities. Forensics is one, but often you'll see a PLC that can't even do any sort of authentication or validation of who's communicating to it. So the whole system is really designed around being safe and reliable, not secure. And it's going to be that way for the next 25 years. David, you've got some thoughts on this too, lots of experience.
Thank you. And yeah, and this is a huge topic. We could spend a lot of time talking about it. I think in the interest of time, we should move on. But I just did want to say that I think ICS networks are still primarily secured with perimeter security models, which the enterprise groups are starting to abandon, right, because those perimeters are so porous. Lisa, any final thoughts here?
I think that it's obvious that the infrastructure poses its own challenges, but I also think that there are challenges posed by the way the infrastructure is evolving into more modern technology and more modern architectures.
I would tend to agree with you. I absolutely agree with you, Lisa. And I'd also agree with something David said, that this industry still thinks it can protect itself by digging a moat and putting a wall around these control systems. And last week, Eugene Kaspersky of the Kaspersky antivirus company talked about how malware was working its way onto the space shuttle and onto the International Space Station. Now, if that isn't an isolated network, nothing is. And it really shows that that's a flawed model. And it gets even more flawed when you actually look at, when you take these historic technologies and you want to wire them all together, and you get a mess like you see on the left-hand side of this slide, where you have little cables running all over the place and all sorts of little networks, and firewalls in some spots, but no firewalls in other spots. And you basically get a lot of insecure connectivity that's rather ad hoc. And we see this all the time, ranging from the situation where you get somebody who will say, oh, our plant's isolated, and when somebody goes and analyzes it, you actually find that there's a dozen connections. In fact, Sean McGurk, who used to be the head of the Department of Homeland Security Division for Control System Security, testified to Congress that on average they see 11 connections from the control system up into the business network in every single site they visit, and some have up to 250. So you currently have this mess, and there's no other word to describe it, of insecure connectivity emerging in most systems. And what we want to move to is this integrated solution that David will talk about.
Thanks, Eric. And enterprises have invested a tremendous amount in an IT intranet, and this is a strategic asset for an enterprise. And enterprises want to leverage it, and in most cases it functions very well. This is exactly what we saw at Boeing. And yet, how can we leverage this to apply security around these different ICS domains without burdening the network itself with this configuration? And then when you start to look at leveraging the global internet, how can you, in most cases, enterprises don't own that infrastructure. So how can we start to add a layer of security on top of that can be separately managed from the ICS equipment itself?
So there are a lot of challenges in this integration, but there's also a very strong set of drivers pushing environments to integrate their IT networks with their control systems networks and to connect that to or across the internet. Some of these business drivers include geographically dispersed systems like an oil company that's managing refineries and pumps all over the world. Consolidation and reducing costs are big priorities for them. Another driver is the improved responsiveness and cost savings you can get from this integration. So oil and natural gas energy brokers in the U.S., initially they were trading based on 30-day-old information, so they need real-time information about the market. And another area that needs real-time data is electric operators who want generation output for managing shortages and selling excess. So these businesses really need to be agile due to the volatile supply and demand or due to just-in-time manufacturing requirements. They want to reduce the cost of maintenance by enabling remote debugging and possibly even remote maintenance. One of the interesting statistics here, cabling in an industrial environment can cost anywhere between $1,000 to $3,000 a foot, depending on the location. So they can possibly save millions of dollars by integrating their ICS networks with their IT networks, reusing existing cabling, if nothing else. They have requirements for compliance, so independent system operators need access to production data in real time to meet these compliance requirements. And ironically, security drives accessibility, which leads to exposure, but the desire for centralized access control to minimize tampering, or for closed-circuit TV monitoring or voice-over-IP access to remote stations. And finally, safety can drive the need to interconnect these networks so that they can be, again, better monitored and better maintained. So all of these are drivers for the increasing integration, but they also lead to increasing risks.
Now, with this comes all these security challenges, and the simplest and the one that's been talked about excessively in the market or in the media is the very simple fact that if an attacker manages to get onto your corporate network, forget if he gets onto the internet, but just assume that they somehow, an attacker or worm or malware gets onto the corporate network. I mean, it has a pretty free run at a lot of PLCs and control equipment out on the plant floor. And who hasn't had something bad show up in their corporate network? It's a reality of life. So these PLCs, these RTUs, the distributed control systems, all of this equipment, again, really was never designed to be secure. It was designed to be safe and reliable. And so if you can ping one, you can basically own them. And if anybody wants to watch some videos, I'll post some videos later or some links to videos later. But it's very, very easy once you have access to be able to get to go after these boxes. So it's really clear that while it's really great to use the infrastructure, the corporate infrastructure, to put your control systems on, there needs to be some sort of controls or protections, or you're leaving your most critical assets in most companies to the whim of whoever or whatever happens to get onto the corporate network. David?
Yeah, I would just add that, Tyson McCulley and Brian Singer, in their book, on cybersecurity for ICS, they mentioned vanilla malware as one of the highest risks of ICS environments. And I think that's because, vanilla malware may not infect a PLC, but it's so aggressive on the network with its communications that it can easily tip one over. And a PLC hasn't necessarily been designed to operate in an environment with a wide variety of network inputs, right? And I think this is a big concern. And this gets us into discussing a potential solution. And this slide depicts the ISA 100.15.01 architecture model, in which these yellow circles, these backhaul interfaces, connect to different underlying networks that are ultimately able to route IP traffic between each other, between the BHIs. The ICS devices have a local connection to these BHIs, and the BHIs function as a transparent bridge between the ICS devices. The BHIs can connect to various underlying networks and perform any network authentication and connectivity management on behalf of the ICS devices. BHIs can even connect to multiple underlying networks as long as there is routing between these different networks to the BHIs. Another point to make here, and this is envisioned in this ISA model, is that this BHI functionality can be implemented anywhere along that vertical line, either in the underlying network infrastructure, as a standalone device as shown, or within the ICS devices themselves. And when standards-based architectures and specifications are used, we have a hope for interoperable products across this implementation spectrum.
And what is interesting about this, and what's maybe not absolutely obvious when you first look at this, is this looks like your standard VPN. But the idea is somewhat different. The idea is to basically allow the industrial control system devices what to them looks like a completely transparent tunnel across the other networks, whatever arbitrary network you want, for them to communicate with each other as if they were all wired together on the same local area network. But it's truly a virtual private LAN rather than a private network. So that they can be even devices that have very, very poor IP capabilities, or even very primitive IP capabilities. But as long as they can connect to a BHI, that BHI looks after all the heavy lifting transparently and looks after both the transport to the other BHIs that it has to talk to, and looks after all the security. So to the PLC, it's just a wire. But to the real world, it's a very closely protected tunnel that is running over potentially multiple different networks.
So there are clearly a lot of benefits to a secure overlay network, but they do also introduce their own set of challenges. You mentioned the ability for the BHIs to set up communication and apply access control across the overlay. But if you have hundreds or possibly even thousands of these BHI devices in a manufacturing environment globally, one of the big challenges is going to be provisioning. There's the need to provision certificates for encrypted communications and for authentication of the device, the need to define the access control policies that will be applied on those BHIs. And if you have to do that statically and individually, that's a huge amount of overhead. There's also a real need for flexibility in these overlay environments based on the geographic dispersal of the sites and the dynamic nature of the communications between them. And it also introduces new challenges for monitoring and maintenance because you have new requirements for visibility into the BHIs themselves and also the potential for multiple administrators accessing and operating this overlay environment. So that's one of the types of problems that the Trusted Computing Group is working to solve. TCG is an industry standards group composed of more than 100 member organizations, including large vendors, small vendors, customers, government liaisons, etc. And we have many work groups focusing on different areas of security, secure storage, secure authentication, and in this case, Trusted Network Connect for network security. Trusted Network Connect is an open architecture for network security that is completely vendor neutral, and it provides strong security through trusted computing. The idea originally behind TNC was to provide an open architecture for network access control. What we realized is there are security problems that plug into a network that aren't necessarily brought by the endpoint. So network access control is a good starting point, but we really need security coordination and security automation throughout the network. So TNC defines open standards so that customers can take security products from multiple vendors, have them all work together. So these standards are well established and widely used. They're freely available on the TCG website, so anyone who chooses to implement them, whether that be a vendor, an open source project, or company that chooses to create vendor-specific or company-specific metadata, it's all available ways to use the TNC standards. There are dozens of products in the market that implement these standards, and hundreds of customers are protecting their networks this way. And David, can you tell us a little how they tie into other standards for ICS?
Absolutely. So the ISA 100.15 has this notion of this private overlay network, as was mentioned. It also has this notion of a configuration interface, and this configuration interface has been tied into the ICS standards, specifically IFMAP. And what we worked on in the IFMAP group is a standard set of metadata that can be used to coordinate and manage the network security policies, network rendezvous, etc., for these VHIs. And also, within the IETF, we are leveraging standards for identity-based communication, so basically this VPN overlay function that ties into PKI. So how can we use enterprise certificates for managing trust relationships? And that also, the trust management challenge is very hard to solve, especially with large sets of distributed machine devices. And we really look to leverage IFMAP's capability for moving orchestration information dynamically through the network. We look to leverage IFMAP for managing those trust relationships.
Thanks. So you've mentioned IFMAP a couple times now. We can talk a little bit about what IFMAP is and what it provides to us. So TNC has a number of services that are enabled by TNC standards, starting with network and endpoint visibility, the ability to see who's on your network, what devices are in use, whether those devices are secure, whether the behavior is appropriate. So you get great visibility using the TNC standards. Also, they allow you to establish a policy for your network to block unauthorized devices, users, or behavior. You can even give different levels of access to different users and devices based on the job they have to do. And if you do find unhealthy devices, you can establish automated remediation to fix them before they get infected or infect someone else. So these two services, the compliance service and the access control service, combine to provide network access control, or NAC. But that's not all TNC supports. The other major area of IFMAP, of TNC, is the IFMAP ecosystem. So a metadata access point is a database that links together multiple security systems so they can share information about what they're seeing on the network, active users and devices, incoming attacks, other devices that they're communicating with, etc. This enables security automation, which is a very powerful tool for coordination in the network. And so this is the orchestration service provided by IFMAP. If you look at the TNC architecture, we start off with an endpoint, which is a device that wants to get on the network. And that possibly talks to an enforcement point to enter the network, or at some point as it traverses the network. So these enforcement points are the guards that grant or deny access based on instructions from the policy server. The policy server is the brains of the operation. It looks at policies configured for the network and decides what level of access should be granted. It instructs the enforcement point, which applies those policies to the endpoint. So these three components are the original components of TNC for the compliance service and the access control service. TNC has also been extended to support a huge number of other networking and security components that might be deployed in our networks to ensure protection. So these could be intrusion detection systems, behavior monitoring systems, leakage detection systems, or in this case, BHIs and the provisioning systems that enable them. So you can enable integration of all those existing systems using the metadata access point, this database that stores information about what's on the network. And it can be queried by map clients that could be policy servers, they could be BHIs, could be provisioning clients, to enable communication across multiple types of network and security devices.
And this integration capability with other producers and consumers of network security metadata through IFMAP is extremely powerful. And the BHIs are acting as these enforcement points. Now, again, what they do, right, the BHIs are connecting to this untrusted IP network, and they can use DHCP and publish their connection to this IP network into IFMAP to enable network rendezvous. And we show here an isolation boundary. And what's happening here is that this isolation boundary or this overlay network is being defined by a collection of cryptographic identities that are baked into these BHIs, right? So what we really have here is a network whitelist of high assurance identities that defines the trust relationship within this overlay network. And this list now is very easy to manage. It's very easy to add and remove or replace identities within this list. And IFMAP is responsible for distributing changes to this configuration in network real time. Right? So each BHI maintains a asynchronous and asynchronous connection to IFMAP to receive these configuration changes. Right? And since the BHIs are acting as this kind of transparent bridge to the ICS devices, the ICS equipment can have its own IP address space independently of how the BHIs connect to this untrusted IP network, right? So it really is transparent. When we're looking for something that's transparent to these existing ICS protocols and provides this layer 2 virtual private LAN service so that it looks like virtual wires are being pulled between these different ICS components. The BHIs should be able to support any kind of connectivity to this untrusted network, any kind of IP network, and perform that authentication on behalf of these ICS devices. Eric, do you have any other thoughts on this slide?
Yeah, I think what's really important here is that by using these overlay networks, you can deal with old legacy SCADA protocols, for example, layer 2 protocols that don't even use TCP/IP, and yet run them over these TCP/IP tunnels. And we've seen this with a number of PLCs that have very old protocols that just don't play well in most environments. But because these tunnels are basically acting as virtual wire over the untrusted IP network, the PLCs don't know. And all the heavy lifting is being done by the BHIs being able to talk back to IFMAP and get their directions, get their, what am I supposed to be doing, and report to the IFMAP server on who they are, what address they might have been assigned by the DHCP in the company, all their sort of important rendezvous information. And so really the important part with IFMAP here is it becomes this clearinghouse of how do I find a particular BHI, how do I talk to it, and am I allowed to talk to it, and do that without bothering the PLCs and the guys on the plant floor. Just make it happen.
So if we go back to our original problem statement of the corporate network allowing an attacker to connect in from a less trusted environment or even from the internet to access devices on the ICS network, David, can you talk us through a little of what happens under the hood with the IFMAP coordination of these protective components? Absolutely.
So the enforcement points are obtaining their security policy configurations from IFMAP as established by a provisioning client, which would typically have some human user associated with it. In response to those security policies, when these ICS devices attempt to communicate with each other, we use the host identity protocol to establish secure communications between the BHI enforcement points. In using HIP, we have the added benefits of an identity-based VPN tunnel that supports mobility and multi-homing and also protects against denial of service attacks. I'd like to point out there is no visibility, no network visibility, no network routing directly across the enforcement point from the corporate network. So this attacker has no visibility of this PLC. So all connectivity between this HMI and PLC is encapsulated in IPsec-like tunnels between the enforcement points. So all the corporate network sees is encrypted data moving around, and there's no visibility into that communication. Meanwhile, the HMI and PLC are communicating as if they are directly connected on this using this OpenHIP virtual wire. Eric, any other thoughts on this?
Yeah, the nice thing about using IFMap for this is, first of all, it's the glue that holds this together. So if all of a sudden an enforcement point it gets assigned a new IP address, that'll break most VPNs. But with IFMap, the enforcement point just needs to publish to the IFMap server, oh, I got handed a new IP address. Now enforcement point A wants to talk to me. We need to, I'll need to rendezvous to a new address. And so it does a lot of the under-the-hood stuff that's really important to keep a system like a control system or a SCADA system running 7/24 without any bumps. And the other thing that I think is really important is that IFMap gives us a lot of extensibility. For example, on one of the projects that you mentioned earlier, David, the airline, there's some interest on making sure that the PLCs are physically located where they are supposed to be, that it's not somebody pretending to be a PLC or a PLC is not on a crawler sitting out in the parking lot. And so it's not difficult to get, say, position location information published up to IFMap and use that as part of your policy, or staff information or hiring information, or IFMap is very extensible. So as long as you can figure out a way to encapsulate that information in an XML format, you can publish it up to IFMap, and then it's not requiring you to rewrite your IFMap database. It's not requiring you, the other devices on the network, to learn new protocols. All it's doing is saying, well, here's some more data that your enforcement points might be able to use someday, if and when they're ready to.
So how can you start to apply the power of these standards to the problem of protecting your environment today? We have a number of suggestions. TCG has released an architect's guide for ICS security using TNC technology. And this is a great starting point. It goes into more detail on the topics that we've discussed today, and it also includes an example of a real-world customer use case. Armed with the information there, that will allow you to start to design ICS security solutions that are standards-based, multi-vendor, but customizable for your unique environment. And you can make sure that that's possible by working with your vendors to acquire TCG-certified ICS security solutions that are based on the TNC and ISA standards. Once you have those components, we are strongly in favor of deploying pilot solutions, observing how they interact with your environment, and then deploying them into production with the confidence that the standards-based technology will enable interoperable protection for you. For more information on TCG technologies and architects guides, you can visit the Trusted Computing Group at our website, www.trustedcomputinggroup.org. And I think we do have some questions in the queue, so go ahead and take a look at that. So, David, what industries would benefit the most from these standards?
Well, I think right now a lot of the pain is in trying to secure industrial environments. And they have a tremendous amount of legacy equipment, including both, the hardened automation equipment as well as the kind of business-type equipment that supports it. Your Windows machines that are used for collecting data or presenting a human-machine interface. It's very difficult to apply patches in these automation environments. And being able to provide a localized moat of security around these high-value industrial assets, I think, is very important. I think one thing that is easy to forget is that these industrial environments are very often what's generating revenue within an enterprise, right? These are the machine tools at a large manufacturer. These are the pipelines for gas and oil distribution, right? These are water treatment plants. And these are the things that we often take for granted but can't really live without in our modern world. And they seem to be woefully underprotected. And so I think having a capability, an architecture, a technology that can easily drop in and provide an additional layer of security and connectivity management to these automation environments, I think that's very important and something we should be looking at right away.
Thanks, David. So it sounds like this is really pretty broadly applicable. And Eric, we have a compound question here that I think you'd probably be the best to answer. 3 parts. First, what kind of systems do you anticipate will be able to embed these new networks? Second, will old networks be retrofitted, or are you anticipating that these new standards will apply only to new systems? And third, how long before we see availability in the market? So I know that's a lot.
Okay, well, I'll see what I can do with that. First of all, what kind of systems? I see it in any system that has either a wide area network component or dispersed assets or assets that are highly mobile and need to use wireless. Certainly in the power industry, in the water industry, in the oil and gas industry, this is a great solution because it can really piggyback on transport systems that exist, the internet, the corporate WAN, and save those thousands of dollars a foot, and yet do it securely and reliably. I think just about anybody who needs to connect one system to the other. Would I use it on my one plant floor if I had like a PLC and a couple HMIs? Nah, probably not. But as soon as you get any complexity, and as soon as you get multiple networks, this is the place to go. Now, your second question is, will old networks need to be retrofitted? And if they did, I wouldn't even be interested in this conversation because those old networks are going to be around for a long time. That's the whole job of the BHI. The whole project at Boeing, for example, that David worked on, was really around being able to just bolt a box in front of the controllers and have that BHI look after the old world. And just basically act as a proxy to solve and sort of, well, in effect, update old equipment to allow it to use new protocols. And that's absolutely critical because I have no faith in everybody in North America or the world tearing out all their old control systems and replacing them with new ones. It's not going to happen until I'm long retired. And availability in the market? Currently, we're producing prototype or actually working product for special uses. It's not widely available, but it is widely deployed at a few client sites. And David, I'm going to pass this to you because I know you're even more advanced in your company as far as getting product out into the market.
Well, thank you, Eric. And so Asgard Networks does have a commercially available product that supports this capability, and we have deployed this and with great success within a variety of industries. And I would encourage anybody to contact me for additional information.
And David, I believe there's also additional information in the attachments to this webinar. Is that correct?
Yes, that is correct. Thank you, Lisa.
Thanks for providing that. So there's a question that I'll take, which is, are the standards you have developed available? And if so, where can I find them? Yes, the open standards from the Trusted Computing Group are freely available on the TCG website, www.trustedcomputinggroup.org. If you are an implementer and you're interested in reading the actual specs, you can go to the Developers section and look under Trusted Network Connect, or you can just search for IFMap. If you're an end user and you want to better understand how you can deploy standards-enabled technologies in your environment, you can go to the Solutions section of the website and look at the Network Access and Identity page, which gives you white papers and other resources. So not only are the standards available, but we've tried to make some materials available to help understand how they can be used. So, David, how did you arrive at the concept of a secure overlay network? And is that a proven concept to enable better security?
Oh, absolutely. I mean, ultimately, this is relying on the same trusted approaches of VLAN, VPN, and firewall. But it's really packaged up differently to really address the needs of these automation environments. And, you know, many PLCs out there can't use DHCP, DNS, even a default gateway. So we had to be able to provide something that was transparent to these automation devices and required no configuration change also, because the last thing people want to do is go around and change hard-coded IP addresses in thousands of pieces of equipment, right? So that was where the overlay concept really came from, was make it transparent to these devices. And the overlay does that, performs that function very well. And then it became the challenge of how do we anchor the communications of this overlay within the shared network infrastructure. And that was where we really found the benefit of the host identity protocol.
Well, thank you. And finally, Eric, what other groups around ICS and SCADA have been involved in this effort?
Well, the primary group that's being involved right now is the International Society of Automation, or ISA. This is probably the leading organization, not probably, is the leading organization for control system professionals in the world. And the two groups that, or two committees that have been most involved in this are the ISA 99, which looks into security for control systems and has published a number of standards, particularly what used to be called ISA 99 and is now called IEC 62443, which is the ISO equivalent to the 27000 series, but for control systems. And the other ISA group that's heavily involved in this is the one that's David referenced earlier, which is ISA 115, which looks at how do we use secure wireless and what is the mechanism to backhaul secure wireless into the control network. Wireless is coming to the plant floor. In fact, it's at the plant floor now. So how do we use it properly? How do we secure it? How do we make it highly reliable? And these are the type of questions that the ISA 115 committee is looking to IFMAP and this strategy to answer.
Well, thank you. That's all the questions we have for now. So I appreciate everyone's time today. I hope this webinar was useful. And for further information, please do check out the ICS Security Using TNC Technology Architects Guide and the other resources available on the Trusted Computing Group website.
Thank you.